right. So, yep, we had our supersized weekend, and now we're ready to jump back into the fun stuff here. So, yeah, I always like supersizing my weekend and the opportunity that it offers it, right? Let's see. Okay, let's look at our grade screen. We've only got one grade so far this semester. We had the 4.01 functions assignment last week. This week, we're looking at modularity, which just means modules, doing things with modules. And then we've got data analysis next week. And then our first program isn't until 4.04 this semester. So data exercise. We've got a couple more weeks here. So let's go back. 4.02 modularity. Modular programming. So if you're in charge of planning some fundraising event, you might start by asking for help because that's a huge job, right? Since you're in charge, you ask friends to come up with plans for the theme, come up with plans for music, come up with plans for the food, etc. Each of these topics can be handled individually. And when you combine the efforts later, then they'll all contribute to some fun event. That's how modular programming works. The idea is that each module, the theme, the music, the food, is built independently, but with related functions, variables, and even runnable code. Then later you can combine all these modules to create an executable application. So, that makes me think. I knew about modular programming before I knew what it was because when I was in high school, I took programming classes with my buddies. We were some of the first programming students to ever go through our high school. It was a brand new program back in the 80s. And me and my buddies, we would play. It wasn't Dungeons and Dragons, but it was a similar game to Dungeons and Dragons. It was called RuneQuest. But you had your characters, you get your weapons, you fight all these crazy creatures and stuff. And so we decided, since we were now computer programmers, we were going to make like a RuneQuest online game. We didn't know that much about programming, but we worked hard on this. So we divided it up. Like one guy, he was building a program that would create a character, and another one was doing like if you wanted to go into a town, like stay at a hotel, he was building that. I was building the weapon shop in the town, and so it's like we each built our sections, and then we'd put it together to make one big program where it would go through. You build your character, you go, you buy your weapons, and then we had working on how to actually fight some creature and stuff. So we learned about modular programming then because I had to use the same variable names for these weapons that the guy who was building the character would use, and the guy that was building how to fight with somebody. You'd have to use the same name. If you had to grab your Warhammer, we had to call the Warhammer the same thing, or else when we put these modules together, it was not going to work. So I don't even remember if we finished it because it became a huge deal because I was trying to do every weapon in the RuneQuest book, which has like, I don't know, 60 weapons. I should have cut it down to just like a handful of weapons, and then it probably would have been a lot easier to write the code. But we learned a lot just trying to do this project on our own and learned about trying to put things together and all that stuff. And so modular programming, I think that's probably how lots and lots of the software we use is because, these programs that you buy and install in your computer, they do so much stuff. You'd have to have a ton of programmers each working on a piece of it and putting it together. So that's where you'd have a lot of documentation over what this variable is. And so you can look it up and make sure you're using the right variable name. But modular programming, it is a big thing in how programming works. So why use modules? To group related code together, right? Perfecting each section of a program before putting it together makes it easy to reuse those sections in other programs because you test that section by itself. To efficiently handle large amounts of data. So big data becomes easier to handle when each module is just responsible for one specific task, just one piece of the data. To make your code easier to understand, so a module keeps all the important details separated. If you want to know this part, you go to this module. Details for each task are housed within the module that's responsible for it. And also reducing errors. Smaller sections of code is easier to debug, right? It helps pinpoint the search for and source of errors or bugs. Because if when you go to do this part is when that error always occurs, you can go to that module and look for the bug. Modularity is everywhere, like an album. Well, an album's made up of songs. A Lego creation is made up of a bunch of individual bricks. A paint by number canvas is made of teeny tiny little shapes. These are all examples of modularity, small parts that when you put them together can add up to something pretty amazing. So, can you think of any other real world examples of modularity? Yeah, everything we do, there's lots of modular. Just think about when you go to at a restaurant, you got someone that's in charge of taking your order and turning in there. You got the cook that's in charge of making the food. He may have some helpers that are responsible for portions of the food. Like I'll make the burger, you make the fries, then they put it on. So it's all modularity, is in practically everything we encounter every day. Importing modules. So coders are all about sharing through forums and open source software, APIs, free online tutorials. You could find information all over the internet about writing code on different things. Importing modules to use in your program certainly fits in this sharing mentality. It could also cut out a lot of work in creating a program. Besides, if someone's already done the coding, why not benefit from it instead of having to rebuild the wheel yourself? So in order to use an existing module in your program, you have to import it, which we have some experience with. You've already most likely used the import statement. Like we imported the turtle when we were doing turtle graphics. We've imported the math function. We've done that. You might have imported the random function if you've done stuck any of the random stuff in your Python code. There are several modules that we have already used, in addition to ones you can find on the internet. So the turtle module, import turtle, define main, name your turtle Tom, go forward 50, turn left 90 degrees, go forward 50. So importing a module is very similar to finding and loading a file on your computer, except it all happens behind the scenes. It's handled by the interpreter. So when the interpreter encounters an important statement, it first checks to see if the module is present in the search path. If it's there, then it imports the module. So if you're not familiar with a certain module, you can check out its documentation to learn about what it's capable of. For example, let's look at the documentation for the Turtle Graphics module. So when you import the Turtle Graphics, what is that importing? I'll click on this, it'll show us what it imports. It imports all of this right here. Turtle motion, the methods it can do, forward, backward, right, left, go to, set position, set X, set Y, set heading, home, circle, dot, stamp, clear stamp, all this other stuff. And I guess there's shortcuts. Instead of forward, you can put FD, it looks like, or BK, or back, or backward. I'll have to try that. Tell turtle state, the position towards the X chord, Y chord. Where's the turtle at? You can check the coordinates, the setting in degrees, the drawing state. Here's all kinds of documentation. When you click on that, and it'll tell you more about it. See down at the bottom, it's got all the parameters for each of those things. So there's the things up here. When you come at the bottom, it tells you exactly how those things work. So you can really get into Turtle Graphics and figure out some really good stuff by getting into all the documentation. Oh, look, changes since 2.6. What else have they done? Because they come out with new versions of Python, and they're showing you what they've changed in the Turtle Graphics. So all kinds of stuff. Pretty interesting. What's interesting that I find too is our version of idle is different than programming one's, because if I copy this code and open up the idle window, I don't know why it's not opening the first time I tried that. There we go. If I open up the idle window and paste this code in there, when I run it, nothing happens. Run, 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 run. Our idle does not have the Turtle Graphics module built in. It can't import it. When it goes to import the turtle, nothing's there. I find that very interesting. So instead, they've given it a Turtle Graphics idle right here. If we want to use Turtle Graphics, we've got to use this other Turtle Graphics idle. So when we paste the code here, it actually opens up a Turtle Graphics module. So they did provide one here in lesson 4.02, but it's separate. Remember, idles don't always run code the same way. That's why we got to have to use the in-course idle instead of just finding somewhere on the internet. If you want to experiment with Turtle Graphics on your own, have fun using this Turtle Graphics idle. So they did provide one if you want to play with the Turtle Graphics, but ours does not include the Turtle Graphics in this version. So interesting. To import a function from a module, you just import the module followed by the function name. Like to import zoom.test. So we can import the function test from the module zoom.py. So let's look and see what that does. Some kind of test we can do here. So let me get rid of this Turtle Graphics stuff that doesn't do anything anyway. Importing functions from module, import zoom.test. File zoom line 1. Okay, that's all it brings in, but I guess it got line 1, and that's all that's in it from this test module. We're gonna look at some better examples here coming up. So all right, let's go do page 3. Importing versus open. So if you're building a doghouse, you're going to need tools like a hammer, a saw, a level. Well, maybe a level. Depends how level you want your doghouse to be. You also need raw materials, like you need some wood planks, you need some nails. Well, programming requires tools and raw materials too. So in Python, you got access to a wide range of tools just by using an import statement. And your raw materials are the data you're using. So in programming, data lives in files like a database. Database is a large collection of data organized for search and retrieval. And you can access those files when using the open command in Python. So let's look how this works. So computer programs use files to store and process data. Oftentimes, files are generated from databases. They're large amounts of data. You don't want to just make a list in your program. You may need a database to keep it all. Websites or programs pull this data from the database when there's a request for information. You think of like a customer accounts for a business. Like you've got accounts at some business and they've got accounts for every customer that uses that same company. So some of those databases could be huge. Can you imagine Walmart's database of all the Walmart.com accounts? You know, there's millions, maybe a billion of those accounts. Python supports several file formats. CSV, which is comma separated value. There's an Excel, zip files, which are condensed text files. JSON, I'm not familiar with those. HTML, websites, PDFs, etc. All kinds of files that Python can use. Python must open the file to access the data and then close it when it's done. So opening files is done like this. To open a file, you got to know its location or file path. Be careful not to move the file after you open it because Python won't be able to locate it. So don't change the file path. The file path is the location of where it's stored in the file, in the folder structure. The file name versus the file path. So a file name is simply just whatever you name that file. The path includes the file name, but where it's located at. So in Windows, like if you've got this text file that you saved, you went to a notepad or Word and you saved hello.txt. To find it in Windows, it says, okay, it's in the C drive, which is your main hard drive. And then you go to the users folder, and then you go to the your name folder, which would probably actually be whatever you logged in Windows as. And then in the My Documents folder, you'll find the hello text.file that I saved. So this would tell Windows exactly where to find your file. In Apple, it's a little different. You don't have to give it the hard drive name. It just assumes the hard drive name. And you give it users and then the your name and then the hello.txt because it doesn't have a My Documents folder. So it's a little different in Apple. Basic commands. Open the file name, comma, R. And the R says, I just want to read the file. I don't plan on editing it. I'm not going to change anything and rewrite it. Just open it up so I can see what's in it. And that's often used with databases if you're just trying to pull up the customer's info. If you're not changing anything, they just need to pull up the customer's info so they can answer questions for them. Or maybe you're opening it so you can write like, oh, they need to place a new order, or they need to change their phone number, or change the address. So I'll need to open it so I can rewrite things and change those things. And then closing it, file variable dot close. So closes a file when the use is complete. So what if a Python program and a file are in the same folder? Oh, that's great, because if your file and your Python program are in the same folder, you just got to do open text file. Right. You don't have to put the C colon. It's in this folder. It's in that folder. If it's in the same folder that Python's in, that's the first place it looks automatically. So all you do is tell it the name of the file, and then are you reading it or are you going to be writing to it? If they're in different folders, then you got to use the entire path. Open, it's in the users folder, the your name folder, it's the text file.txt. So you got to include all that if it's somewhere different. When working with files in Python, it's important to stay organized in file documents as they're created. Here's some best practices to keep in mind. Keep your programming files on one main folder. That sure makes things easier. Use plain language to name your files. Don't put initials, don't put random words. If you look at the name of a file, it should give you some idea of what that file is. That helps a lot. Nest folders as needed. Like I'm going to put my programming file, and then I'm going to put, oh, here's all my files for this one class. So I'm going to create a folder for this class, and I'll keep all those program files in there. But it says don't go overboard. Don't have to go down into 8 folders inside of each other to get to something, because that's going to be a big pain if you ever have to open it and list all those folders. Just do some basic organization. And don't forget to back up your files regularly, because you lose it, you got to start over. Page 4, just add data. So you're ready to level up your Python skills. So ask any programmer working with different file types and importing modules into a program are must-have skills for efficiently writing great programs of practical code. So let's look at these guided activities. So we've got 4 slides here. Read the code, predict the output, run the program. So we have our main function and a comment. Open files with the name text.txt. So we set a variable and we call it just F, I guess, for file or something here. And we're going to open text.txt, which is apparently saved in the same folder as where our Python program is found, because we didn't put any other thing in there. And we just want to read what's in there. Now this says print from that F, because we saved it in F, read 4. Now what this does is that will pull the first 4 characters from that text. We said, give me the first 4 characters and print that. And then we're going to print again. And the second time we said, print the whole thing. Print the whole thing. First time we said, just print the first 4 characters. And this says print everything that's in there. So let's take a look at this text.txt file to see what's in it. Oh, so the first time we printed, we just pulled the first 4 characters, this. Then we printed the whole thing. This is a text file. So you can see how Python can open a text file. So there's 3 lines in that text file. And we can pull out just characters, or we can print the whole thing. So that's neat. Some text file that's been saved in a folder where Python is being saved, and we can just pull up this text.txt. So I wonder if it's also in our idle. Let's check it in our idle, just since we have this. Okay. Yes, it's in the same place our idle is held. So we can use that text.txt in any program because it's there and this is what's stored in it. All right, let's go to the next example. All right, we're taking that same text.txt again, saving it in our F variable again. Now we're creating a list, an empty list called my list. Now we're going to use a loop for however many lines there are, and we're going to add to my list, each line that's in here. And then we're going to print the list. So basically we're opening that text file and we're copying it into a list and then printing the list. And then we're closing the file. So we're just copying everything in there into our current program so we can use it. When we run it, Okay, here's the first item in the list. It's in these individual quotes. This is a text file. And this is a carriage return. That's all the slashes with an N. That's saying, okay, this is the end of the line. Go to a new line. So it saves that as part of the text file. This is a text file / N. And then here's the second item. Now, things in the list are separated by a comma. So the second thing is, so you can see how, and then there's a carriage return. And then the last thing is Python can open a text file. And notice there's no new line there because that's the last line in the file. So these say go to a new line there. So we saved it into a list and then just printed the list. So there's what was in text.txt, 3 lines. Now let's look at this third one. F equals, again, we're saving the text file in a variable called F. Now we're taking my list 1, and it's going to equal F dot read the lines inside F. So in that text file, we're going to read lines. So I guess that's a Python command to read the lines in this text. So first we're going to print my list 1, which is what we call the list. So it's going to print the whole thing. And then it's going to print the first item in the list, right? Which is going to be the second item, right? Because it starts counting a 0. We're not printing the 0 item in the list. We're printing the 1 item. So it's going to print the second line from that list. Let's run it and see what it does. There's the list. This is the text file. So you can see how Python can open a text file. And so when we print the first item, it skipped the 0 item. We didn't print that. We printed the 1 item. So you can see how. Which means we could change that. If we wanted to print the last one, Python can open a text file. We change it to this number 2 item in the list, 0, 1, 2. So this is an interesting way that we pull in from a database, and then we can play with the information once we get it in here. Okay, here's our last slide. Again, F equals, and we're reading it all in there, and we're just printing it all. And it wants us to modify the code so that only the third line is printed. Well, let's run it first. Okay, there's the whole thing. It just wants us to print the third line. So that would be 2, right? Or do I have to put that? I got to put that in brackets, don't I? Yeah. When calling items from a list, they go in brackets, not parentheses. So if I want to print the third line, that'd be number 2, since Python starts counting to 0. Python can open a text file. So we've modified the code so the third line of text is printed from the file. All right, so this is giving us a good preview because 2 weeks from now, we're going to do something like this. We're going to have a data file that we're going to pull information from. So we're starting to learn key commands and how to pull in that data and how to manipulate it. We do have a programmer spotlight on Elon Musk, harnessing the power of data for the good of mankind. You may know him as the founder of some high-tech companies like Tesla, SpaceX, but before these epic achievements, Elon Musk was a kid who liked to code. He taught himself computer programming at the age of 12. Sharp guy. Igniting his curiosity and inspiring him to pursue a career where he could change the world. And I got to say, if anyone's changed the world, it's certainly Elon Musk with his Starlink, providing internet anywhere in the world, Tesla, his SpaceX program. It's crazy. And as an entrepreneur, Musk is no stranger to using the power of data to make decisions and think big, really big. He's made a name for himself by planning the future colonization of Mars. That's what he's doing with this SpaceX thing, is he's trying to figure out how can we live on Mars, and he's trying to develop all the technology to be able to actually move people to Mars if they want to go. So he's figuring out how to reuse rocket boosters, making strides that will one day allow sustainable energy use and production on a wide scale. Because if we're going to live on Mars, we're going to have to produce our own energy there. So I'm going to mention this. I saw an interview with Elon Musk recently where he's talking about AI, and he's this dude's a genius because he's been in programming, and his technology's so far ahead. He's got a medical company that's working on implants that go in your brain, and if you're paralyzed, those implants can actually make unparalyzed. It can make you move body parts that haven't moved in years. So, I mean, he is really trying to help mankind. But his opinion on AI, and I don't know how right he is, but by golly, how many times has he proved people wrong? He says, like in 15 to 20 years, most people are not going to need a job because AI is going to be able to produce resources and everything so cheaply that everybody just get everything they want. Whatever you need, it'll be able to produce food, it'll be able to produce materials and clothing, and using AI, he thinks it's going to advance civilization so much that we won't even have to work because all of our needs will be met by AI. Interesting thought. I hate to say I don't believe it because he's proven people wrong again and again and again, but I don't know. We'll see what it looks like in 15 or 20 years. So interesting thoughts. I thought that was a bit of a stretch, but prove him wrong, right? All right, that's the end of this lesson. Let's look at our assignment that goes with that. What's an advantage of using modular programming? So here is some code. The module contains a greeting function, returning a nicely edited greeting. Unfortunately, this code generates an error message. Where's the error? So somewhere in here is an error. So we have to go back and look. How does the import work? Maybe this is wrong. This is just defining a function. Greeting message, say hello, Jessica. So somewhere in there, got to look back at the commands we've used in this code. Figure out which one of these lines is wrong. Which statement tells the code to use the existing module supermodule? Is it get supermodule, import supermodule, load supermodule, or use supermodule? I think we know that one, the import statement. Which of the following is possible file path? So we talked about how file paths work. Which one of those is accurate? Some of those wouldn't work. We're trying to import this text file, apparently. Select the correct line of code to open the text file. Author for writing. You want to write to that author code there. So, all right, getting into the fun stuff. Some advanced programming type skills here. Being able to pull data from other databases instead of having to write everything into your code. Create your own lists and that kind of fun stuff. So, all right, step one in getting there. By a couple more weeks, we should know enough to be able to write some code to actually do this. So get into the fun stuff. So having fun with this, guys. Play around with it. Let's learn how to open databases, pull in files, that kind of stuff. And guess that's it. So we'll get you guys next time. Let's see, this is Wednesday, so there's no more A days this week because Friday's not class days anymore. So, all right, if you got questions, email me. We'll get you guys later.